Hello everybody, welcome to my first ever tutorial. Miming-chan here. First of all, I'd like to apologize for my poor English. It's not my native tongue, you see. And although I'm good at writing in English, I'm not that good at speaking in English. So let's proceed. What am I going to teach you anyway? It's about database design. And before watching this tutorial, I assume you've already learned a few topics. They are: first, knowledge on how to make entity relationship diagrams, and you also have to know what ERDs are. Second, knowledge of the purpose of database management systems, especially the relational database management system, because this is focused on RDBMS. And third, have to have knowledge on what an information system is, because this tutorial is mainly aimed for DB design in the IS development process. And lastly, you have to have knowledge on what the topic is. So you need to have an idea on what I'm talking about. Okay, let's have part 1, Introduction. I'll just mainly define a few key terms, which I suspect most of you already know, so if you get bored, you can proceed to part 2, Logical DB Design, okay? Okay. So let's start with the importance of DB design in the IS development process. Why is DB design so important anyway? The purpose of an IS is to provide information, right? And take note that database, or DB, is one of the critical pillars of an information system, since data, the rough source of information to be provided by an IS, is stored and managed in the DB. If not designed properly, the DB could fail, and since it is one of the critical pillars of an IS, failure of the DB means failure of the IS. Before we proceed, let's define a few key terms. First in the list, we have relational database. A relational database is basically data represented as a set of related tables. That's why you should have first knowledge about RDBMS before watching this tutorial. And then we have a second key term. Second key term is relation. A relation is a named two-dimensional table of data. Table, relation. I will use these words interchangeably throughout the tutorial, so get used to it. And each relation consists of a set of named columns, also known as fields or attributes, and an arbitrary number of unnamed rows, also known as records. So basically, a relation is a table in your DB. To discuss relations further, let's talk about its properties. Here we have the student relation. First property, entries in cells are simple. Second property, entries and columns are from the same set of values. If I say year level field is of numeric type with length 1, then I can only enter numbers 0 to 9. I can put an 11, a 100, or even letter A, B, C, D, because that's beside the boundaries. If I say first name field is of text type with a maximum length of 20, then I cannot put text with more than 20 characters. Third property, each row should be unique. Why do rows have to be unique? Let's say, for example, that we had 2 copies of this last row here. This record with student ID 2009-87652. Since the 2 records are identical, redundant, and not unique, both records will refer to one student only. But if I look for how many students with the first name John Carlos there are, the DBMS will return the value 2, which is wrong, because although there are 2 records, the relation with first name John Carlos, both records actually refer to only one student instance. This is an inconsistency in the resulting IS, and it could also cause problems regarding referential integrity. Fourth property. The sequence of columns can be interchanged without changing the meaning or use of the relation. If I exchange the order of fields, course ID, and year level, Ma and Cara Allegra's year level will still be 4. Leon July's course ID will still be CFA. The data within the fields of every record do not change. Fifth property. The rows may be interchanged or stored in any sequence. The order of the rows don't matter. If I exchange these two rows here, the student with student ID 45679 will still be Pilar Delegado. Okay, for our third key term, we have primary key or PK. A primary key is an attribute whose value is unique or non-redundant for all records in a relation. All relations have a primary key, and primary keys can be composed of single or multiple fields. Remember in the previous slide, I said that all rows in a relation should be unique, right? The primary key basically handles that for us since the primary key is unique and it exists in all relations. Let's take a look at our previous example, the student relation. The primary key here is the field student ID. A primary key determines the whole record and every field data of the record for that matter. So let's say, what is 2009 617 98's first name? That would be Leon July. What is 2009 45679's last name? That would be Delegado. It's like that. Even if there are 2 or more students with last name Delegado, the PK will refer to this row only. That's why PKs need to be unique and mandatory. Null values are not allowed. Now let's have our fourth key term. Foreign key or FK. A foreign key is an attribute in one relation which is a primary key attribute in another relation. It connects one relation with another, thereby establishing a relationship between relations. Going back to our previous example, the student relation, we identify the foreign key with a dashed underline. In this case, it's our course ID field. This foreign key references from the PK of the course relation, and that is course ID as well. The reference needs to be a PK. This is because it would be difficult, or rather impossible, to determine what record the FK is referring to if the reference is not unique. For example, let's say BS Mathematics also has course ID BSM. Let's do that. Okay. Okay. Let's say this is also BSM. Now, what then is Pilar Delegado's course ID BSM referring to? Would that be BSM as in management or mathematics? And same goes for the record John Carlos de Luna. The fifth And last key term is a goal of database design. Well-structured relation. A well-structured relation is a relation that contains a minimum amount of redundancy and allows users to insert, modify, delete the rows without errors or inconsistencies. A relation with a minimum amount of redundancy to avoid errors or inconsistencies. In other words, a well-structured relation is a properly normalized relation. But what does normalize mean? We'll answer that in part 2, logical database design.